In this video, we're going to talk about how to solve quadratic inequalities by graphing. So to solve quadratic inequalities by graphing, we're going to type each side of the inequality into Desmos as a separate function. Then we'll identify the points of intersection. Remember to use the inequality sign to decide whether the endpoints are included. Then we'll determine which values of x correspond to y values that make the inequality true and include these values in the solution set. So for example, let's suppose we're trying to solve x squared plus 3x is less than or equal to 10. So I'm going to call this left side a function of y, and I'm going to turn this right side into a function of y. So I'll have y equals x squared plus 3x, and then I have y equals 10. So to solve this, I'm going to go to Desmos and type in these two functions. So I have y equals x squared plus 3x, and then I also have y equals 10. So you can see here I have two intersection points, and when you click on those in Desmos, remember it will give you the coordinates. So we have coordinates 2, 10, and negative 5, 10. So what I do is I kind of sketch a number line for myself, and I'm going to put those two intersection points at the x values on my number line. So I have negative 5 and 2, and since this is a less than or equal to sign, I'm going to put filled in circles at those endpoints. So now we want to think about what this inequality is telling us. We know that x squared plus 3x is the parabola that we have on our graph. So this is saying look for places where the parabola is less than or equal to the line. We can see on our graph that our parabola is below the line right here between this point and this point, right? So like in this section right here, our parabola is below the line. If we look for sections beyond those endpoints, notice that the parabola is above the line. And you can see this a little bit better in Desmos. The parabola is below the line only in this region right here, and then anything beyond that, the parabola moves above the line. So that means that we're looking for the region that's between negative 5 and 2, and we can write that in interval notation as negative 5 to 2. And remember, we can write that as negative 5 is less than or equal to x, which is less than or equal to 2. So let's try solving now. X squared is less than 25. So that's going to be a y, and this is going to be another y, right? So we'll have y equals x squared, and then we have y equals 25. So let's go ahead now and graph in Desmos. So we have y equals x squared, and then our next function will be y equals 25. Okay, so now if we look at this and if we click on both endpoints, we have endpoints at negative 525 and 525. So if we graph this on the number line, we have negative 5 and we have positive 5. So since we have a less than sign, we're going to have open circles at both of these endpoints. So this is asking us to look for places once again where the parabola is less than the line and the parabola is below our line in this region right here, right? So here we have a region where the parabola is below the line. So we'll say that it goes from negative 5 to 5 and the endpoints are not included. So we'll say negative 5 to 5. In other words, negative 5 is less than x, which is less than 5. So now you can go ahead and pause the video and try doing this example on your own. So I entered this inequality as two separate functions in Desmos. So I have y equals x squared minus 5x and y equals 6. This is asking us to look for places where the parabola is below the line. And you can see that the parabola is below the line in the region going from negative 1 to 6. Since my endpoints are both included, I'm going to use square brackets to describe this interval. And I can also write this as negative 1 is less than or equal to x, which is less than or equal to 6. So now let's try this example. We have x squared plus 8x is greater than 20. So if I separate this into two functions, I have y equals x squared plus 8x, and I have y equals 20. And let's go ahead now and enter this into Desmos. So we have y equals x squared plus 8x, and then we have y equals 20. Okay, so if we click on those two endpoints, we can see that these are the two endpoints that I'm going to sketch on my number line. So I have negative 10 and I have positive 2. All right, so now let's think about what this inequality is saying. It's saying look for places where the parabola is above the line. So if we look for places where the parabola is above the line, you can see that it is above the line in this region going from this endpoint to the left, and it is above the line in this region going from this endpoint to the right. So if I were to sketch this on my number line, it would look like this side right here, and then this side on the left right here. Also, since I have a greater than sign, I know I'm going to have an open circle at both of these endpoints. So if I was going to write this in interval notation, I would say this is negative infinity to negative 10 union 2 to infinity. Okay, if I was going to write this as an inequality, I would say x is less than negative 10 and x is greater than 2. Okay, so now you can go ahead and pause the video and try doing this example on your own. So here we have x squared is greater than or equal to 49. So if I type this in as two separate functions in Desmos, I have y equals x squared and y equals 49. Notice that I have two intersection points. So I have -7 equals x as one endpoint, and I have x equals 7 as my other endpoint. I'm looking for places where my parabola is above the line, and that'll be this region to the right of 7, and this region also to the left of -7. So if I were to write that in interval notation, it'd be -infinity to -7. -7 is included because I have a greater than or equal to sign. And then I use the union symbol for the interval from 7 to +infinity. Once again, 7 is included with a square bracket because of my inequality sign. If I was going to write this as inequalities, I'd have x is less than or equal to -7 and x is greater than or equal to +7. So remember, you can solve quadratic inequalities by graphing each side of the inequality in Desmos and looking for the endpoints. Remember that the inequality signs determine whether the endpoint is included, and look at the relationship between the functions with respect to the inequality sign to determine the solution set.